All right, this video is going to show how to solve some polynomial equations by factoring. So we're going to start off with the first problem. The first problem is 6x to the fourth minus 54x squared equals 0. And step one is always to set the equation equal to 0. So this equation is already set equal to 0, so we don't have to worry about that. The next thing I'm going to do is I'm going to look for a GCF. And so the greatest common factor, both of these terms divide by a 6 and they both divide by an x squared. So I'm going to take out a 6x squared. So 6x to the fourth divided by 6x squared is going to give me x squared. 54x squared divided by 6x squared is going to give me minus 9. And so once I have factored out a GCF, if I want to, this part right here will factor further. That's actually difference of perfect squares. So that in parentheses is going to factor into x minus 3 and x plus 3. And how you get that is you square root x squared, and that gives you an x here and an x here. And you square root 9, and that gives you the 3 here and the 3 here, and one's a plus and one's a minus always with difference of perfect squares. So finally, the last thing that I'm going to do is I'm going to set each one of these factors equal to 0. So 6x squared equals 0, x minus 3 equals 0, and x plus 3 equals 0. So this first one I'm going to go ahead and divide by 6. So 0 divided by 6 is 0. So I have x squared equals 0. Then I'm going to square root both sides. Normally you would have plus or minus, but there's no such thing as plus or minus 0. So I'm going to have x equals 0 and x equals 0. So we know it has to have two answers because of the squared here. It has to have two answers. So this one right here, I'm going to add 3. So x equals 3. And this one I'm going to subtract 3. So x equals negative 3. So this was a fourth degree polynomial equation. So it has to have four answers. So my four answers are x equals 0, and x equals 0, x equals 3, and x equals negative 3. So we say that 0 has a multiplicity of 2 because it shows up twice. And so those are my four answers. So this, if I graphed it, these would be the four places that it would cross the x-axis. All right, the last problem here. This problem is not set equal to 0, so that's the first thing that I'm going to do. So I'm going to move the 4x over to this side and the 4 over to this side. So I have x cubed plus x minus 4x minus 4 equal to 0. So anytime I have a 4 term, I'm going to go right to grouping. So I'm going to group the first two together and the last two together. The first two I'm going to take out an x squared, and I get x plus 1. And the last two here, I'm going to take out a negative 4, and I get x plus 1. Again, you want these to match, which they do. So once they match, my factors are the parenthesis that matches, which is x plus 1, and then what I factored out, which is x squared minus 4. Now, we can either stop there or we can factor this further. This is difference of perfect squares again. Remember, those two have to both be perfect squares, and it has to be a subtraction problem, which it is. So the square root of x squared is x, so put an x here and an x here. The square root of 4 is 2, so I put a 2 here and a 2 here, make one a plus and one a minus. So I end up with my three factors as x plus 1, x plus 2, and x minus 2. So if I set each one of these equal to 0, I'm going to get my three answers. So my three answers are negative 1, negative 2, and positive 2 are my three answers. Again, this is a third degree equation, so I know it has to have three possible answers, whether they're imaginary or real answers. Imaginary answers have to run in pairs, so this particular problem would have had to have two imaginary and one real, but they all turned out to be real answers. All right, so let's look at this next problem. This one is a trinomial, and so I'm going to use the trinomial method to factor this one. Even though this is an x to the fourth equation, we can still use a t-chart method or the trinomial method. The AC method is what some teachers call it, to factor this. So I'm going to take the leading coefficient, which is 1, times the constant term, which is -9. That gives me -9. I'm going to make a little t-chart. And I'm going to look for my middle term, which is -8. So on this side is a times c, and this side is b, because my equation is in the ax squared plus bx plus c form. So two numbers that multiply together to give me -9, and at the same time to add to be -8. So -9 times 1 is -9, and -9 plus 1 is -8. Once you find those two numbers, you're going to rewrite that middle term into those. So I'm going to rewrite this to x to the fourth minus 9x squared plus 1x squared minus 9 equals 0. So then I'm going to factor these two together and these two together. And so these first two terms have an x squared in common. So x to the fourth divided by x squared is x squared. -9x squared divided by x squared is -9. And these two have nothing in common, so I have to take something out. So I'm going to take out a +1, and that doesn't change anything. So your whole idea is to get those to match, which they do. So my factors are x squared minus 9 and x squared plus 1. So the next thing that I do is I set each one of those factors equal to 0. And solve. Now I could have, if I wanted to, I could have factored this one into x minus 3 and x plus 3 using difference of perfect squares like we did on the last one. But this second one here does not factor because that's a plus sign. It has to be subtraction in order to factor. But since I forgot to do that, the other way I'm going to do is I'm going to just simply add 9 and x squared equals 9, and then I can square root both sides. So x is equal to plus or minus 3. So either way I'm going to get plus or minus 3. On this one right here, since I can't factor it, I'm going to subtract 1. So x squared equals -1. I'm going to square root. Well, the square root of a -1, that's an imaginary answer. So x is equal to plus or minus I, my imaginary answer. So this particular problem, again, it's fourth degree. So it has 4 answers. My 4 answers are x equals 3, x equals -3, x equals I, and x equals -I. So it has 2 real solutions, which are 3 and -3, and that's where it would cross the x-axis if you graphed it, and it would have 2 imaginary solutions, positive I and negative I.